Heavenly Father, we just thank you for the day, thank you for the blessings you've given us, thank you for the opportunity, Lord, that we be here in school. Just pray that we continue to be in Reagan, Lord, and help her to become healthy again, Lord, that she'll be able to do the things that she wants to do. I just pray to help the students in their classes this week, especially before spring break. Help them to be diligent and focused in their work, Lord. In Jesus' name, amen. All right, so let's deal with some principal values. Principal values are the values that your calculator will give you. And it's always just one answer. Okay? Principal values for sine is?
What do you mean?
Where are my principal values for sine?
First and fourth.
Alright, from negative pi over 2 to pi over 2. So when we look at this, we're really looking at our number line. We really got first quadrant and fourth quadrant. Sine is negative where?
It's negative in the fourth.
Fourth quadrant. Sine is positive where?
The first.
So our principal values, we're always dealing with reference angles. Reference angles. If it's in the fourth quadrant, it's going to be a negative reference angle. If it's in the first quadrant, it's going to be a positive reference angle. So if I ask for the arc sine, all right, so I'm talking about principal values, arc sine of 1/2. What angle do I take the sine of that will give me 1/2? Pi over 6. It is positive, so I want the angle in the first quadrant, so it would be pi over 6. If I say I want the arc sine that is negative 1/2, what do I take the sine of that is 1/2? Pi over 6. But where is sine negative?
The fourth.
So I want the angle in the fourth quadrant, so it would be negative pi over 6. Right? Because it has to be between 0 and negative pi over 2. Right? Different than when I ask, alright, I want the angles between 0 and 2 pi. If I say I want the angles between 0 and 2 pi, I'm looking for what type of angle?
Not the reference angle, but there's a special name.
You're thinking a little bit more than I'm looking for. If I'm looking for a angle between 0 and 2 pi, I'm looking for what kind of angle? A positive angle. A positive angle.
Really special.
0 to 2 pi, right? Okay? If I'm looking between 0 and 2 pi, how many answers should I have?
2.
I should have 2 answers, because there's always 2 quadrants where the angle is positive or negative. So we could go pi, we could go 3 pi over 2, and we can go to 2 pi. First, second, third, and fourth. Fourth quadrants. So we can go either way depending on what direction we want. But between 0 and 2 pi, so if I ask for the sine, or the arc sine of 1/2, again, I'm looking at what reference angle? Pi over 6. And sine is positive where? First and the second. So I'm looking for the pi over 6 in the first quadrant, which is? Pi over 6. I'm looking for a pi over 6 in the second quadrant, which would be?
5 pi over 6.
5 pi over 6. So there's the 2 angles I'm looking for.
So whenever it's between 0 and 2 pi, there's always 2 answers.
Right? Think about the quadrants that they're asking you to be. Alright? 0 to 2 pi. Alright, I'm talking about first quadrant, second quadrant, third quadrant, and fourth quadrant.
Okay, so if it was negative, would we find it in the third and fourth quadrant?
If I say from 0 to negative 2 pi, then I'm going backwards in the fourth, third, second, and the first.
So,
And I want what type of angle?
you want negative
A
angle.
negative angle.
So if we did negative 0 to negative 2 pi, would it be negative 11 pi over 6 in the fourth, and
Not in the fourth, because again, if I look for the arc sine of 1/2, I'm still talking about a positive value, right? Where is sine positive?
first and second.
first and second.
Yeah. But if it was negative, would it be different?
So I'm going this direction first.
Mm-hmm.
Alright, so I'm talking about here and here, because it's still positive in the first and second quadrant.
Mm-hmm.
But I could have a negative angle.
Mm-hmm.
So I need a pi over 6
Mm-hmm.
in the second quadrant, which is really the, which quadrant going
Third.
clockwise?
Third quadrant.
Third quadrant. So it would be,
5 pi over 6 or 7 pi over 6?
what's that?
No, it would still be 5 pi.
Remember, what kind of angle we're looking for?
Positive.
No.
Negative.
Negative. So pi over 6 here, you had the numbers right, but you had the SIGN wrong. So negative 7 pi over 6
Uh-huh.
would put me in the second quadrant.
Uh-huh.
And then to get to the first quadrant, you were right earlier to an extent,
Uh-huh.
would be, it would be what?
Negative 11 pi over 6?
Negative 11 pi over 6.
So we're looking for a 1 over 2.
The arc sine of 1/2, which is positive, so it's in the first and the second quadrant, but it depends on which way I'm gonna go. And 5 pi over 6. If I'm going from 0 to 2 pi, it's the first and second quadrant. Pi over 6, and then not 6 pi over 6, but 5 pi over 6. But if I'm going clockwise, I gotta get all the way back to the second quadrant and to the first quadrant.
So it's gonna be negative pi, between negative pi, negative 2 pi.
It's from 0 to negative 2 pi. First, second, and third quadrant clockwise. All right, so principal values. Cosine negative square root of 3 over 2. What do I take the cosine of? That would give me square root of 3 over 2. Pi over 6. Principal values for cosine is where?
The first and third.
First and second.
First and second.
0 to pi. Alright, 0 to pi. So principal values for cosine, there's no negative angles for principal values for cosine. There is for sine, but not for cosine. Alright, where is cosine negative?
The second.
Second quadrant. So I need a pi over 6 in the second quadrant. 5 pi over 6.
How do you know it's the first and second again?
Because my principal values for cosine is from 0 to pi.
Okay.
Right? And again, as I wrote these down, when we talked about these, sine, negative pi over 2 to pi over 2, cosine, 0 to pi, and tangent, negative pi over 2 to pi over 2. Alright, you should have those written down in your notes someplace, but if you didn't write them down when you should have, but you should write them down now. Sine, first and fourth, cosine, first and second, tangent, first and fourth. This is 0, this is 0, and this is pi over 2. Alright, fourth and first, first and second, fourth and first. Sine and tangent, you will have negative principal values. And you will see this when you do it on your calculator, because that's what your calculator gives you, principal values. There's going to be other times where I give you a specific place I want you to give me the angle. A lot of times it's between 0 and 2 pi. Sometimes it's switched up to make it negative or whatever. So here, principal values, 5 pi over 6. What if I want it between 0 and 2 pi?
And
where's cosine negative?
It's negative in the second,
And the
third,
third. So here's my 5 pi over 6. Now I need a pi over 6 in the third.
so it would be 7 pi over 6.
7 pi over 6. Correct.
And how did you get that again?
Because 6 pi over 6 is what you have for pi, so you just add 1.
Is it cosine negative 1 negative sort of 3 over 2 or?
Yeah, it should be our cosine.
So how can you get 5 pi over 6 in repayment?
Where's my reference angle?
Pi over 6?
And where's cosine negative?
Second and third,
Principal values would be the, what quadrant?
second,
Second. What is a pi over 6 in the second quadrant?
5 pi over 6. So what is 7 pi over 6 for?
If I ask for the angles between 0 and 2 pi. Where's cosine negative? Excuse me?
Fourth, third quadrant.
Alright, second and third. 5 pi over 6 is the second. What is pi over 6 in the third?
Oh, 7 pi over 6.
7 pi over 6.
So we're looking for 2 answers.
If I give you 4 quadrants, yes, I'm looking for 2 answers. But folks, those of you that still having struggles with this, you gotta remember your reference points. Pi is your reference point. You're either there and gone by, or you're not there yet. So you're either subtracting, or you're adding the reference angle. Pi is always the same number of pi over the number as the denominator you want. Pi is the same thing as 10 pi over 10, 12 pi over 12, 15 pi over 15, 100 pi over 100, and so on and so on and so on. You've got to remember that's my reference point, right here. Second quadrant, I'm not there yet, so I subtract from pi. Third quadrant, I'm gone by, so I add to pi. Fourth quadrant, I'm not to 2 pi yet, so I subtract from 2 pi to find that angle. I can't explain it any simpler. I can't explain it any different. You just got to remember, this is my reference point right here. Am I there yet, or have I gone past it? If you've gone past it, you're going to add to it. If you're not there yet, you're going to subtract from it. Same thing with 2 pi. 2 pi is the same thing as how many pi over 6? 12 pi. 2 pi is the same thing as how many pi over 10? 20 pi. 2 pi is the same thing as how many pi over 30? 60 pi over 30. Okay? So you should be able to get those fairly easy to be able to subtract. Principal values and others. Let's look at another one.
Negative pi
Oops, more of that.
1.
Arctangent, negative square root of 3. What's my reference rank? What's my reference angle?
Pi over 3.
Pi over 3. What quadrant is tangent negative in?
It's negative in
Second.
fourth and second.
So with my principal values?
Fourth.
Fourth quadrant, my principal values?
Fourth.
Fourth quadrant, my principal values?
Fourth.
Everybody, principal values?
Fourth.
Where's tangent negative, the principal values?
Fourth.
Alright, my angle would be negative. So what's my answer for the tangent -1 of negative square root of 3?
Negative 5 pi over 3.
Negative pi over 3.
Oh, because it's going that way, so it's not.
Again, sine and cosine, sine and tangent are always my reference angles. It's either a positive reference angle or a negative reference angle. Don't have to, it's not too much. All you have to do to remember is, okay, what is my reference angle? Other than that, if it's in the fourth quadrant, it's going to be negative. If it's in the first quadrant, it's going to be positive. Alright, my reference angle here is pi over 3, but it's in the fourth quadrant, so it's negative pi over 3. Alright, if this was positive, then it would be pi over 3. Alright, so switch this up a little bit, alright? My reference angle we know is pi over 3, right? I want the angle between 0 and 2 pi.
So then you would do the clockwise thing, so then you'd have.
Counterclockwise.
Counterclockwise.
Tangent is negative where?
Second and the fourth.
Second and the fourth. So I need a pi over 3 in the second.
It would be
And
2
you
pi
guys are too
over 3,
slow.
Or 4 pi over 3. 2 pi or 4 pi?
I'm in the second quadrant.
2 pi over 3?
Everyone, I'm in the second quadrant. Come on, everyone, I'm in the second quadrant. Pi over 3 in the second quadrant.
2 pi over 3.
Everybody agree? Have I gotten to pi yet?
No.
I'm gonna do what?
Subtract
Subtract. Pi is the same thing as what over 3?
3.
3 pi over 3. So I subtract 1 from 3, I get
2.
2 pi over 3.
Why wouldn't it be clockwise, Mr. McLaughlin?
I want it between 0 and 2 pi.
Yeah, but if we did 0 and 2 pi for the last one, that was negative, we went counterclockwise. I mean, we went clockwise, but now we're
Because
going.
I asked for between negative 0 and negative 2 pi.
Okay, got it.
Yeah.
My bad, I'm sorry.
That's all right.
What, the fourth quadrant that we had for.
All right, fourth quadrant. My reference point is what?
It would be
What's my reference point? Fourth quadrant.
5
5.
3,
No.
Reference point. What's my fourth quadrant? Reference point.
negative pi over 2.
No, my reference points are either pi or
2 pi.
2 pi.
So
2 pi.
Pi or 2 pi.
2 pi. So
Have I got there yet?
No, so it's 5 pi
No.
over 3.
All right.
It's-
How many pi over 3 is
6.
2 pi?
6.
6 pi. Have I gotten there yet?
No,
So I'm gonna do what?
subtract 1.
Subtract. So I get what?
5 pi over 3.
5 pi over
What are you
3.
subtracting?
Oh,
My reference point.
Pi over 3.
My reference point.
2 pi minus pi over 3.
My reference point. Yep.
But I thought
But
we
you,
just.
folks, you gotta picture this in your mind. You gotta draw a mental picture in your mind. I am going from here to here. Right? Even if you forget, even if you don't memorize it, if you picture this mental picture, you should be able to figure out, hey, I gotta subtract that from 2 pi. It just number theory in numbers. 2 pi is 6 pi over 3. I didn't get there yet. How far am I away? Well, I'm pi over 3 away, so therefore I'm where? 5 pi over 3. You gotta picture that picture in your mind.
Why is that negative pi over 3 because it's supposed to
Because
be.
I asked for the angle between 0 and 2 pi. 0 and 2 pi.
So why is it negative pi over 3?
I didn't say it was negative pi over 3. We said it was 5 pi over 3.
At one time it'd be negative, so 0 to negative 2 pi.
So when we use reference angle, when will we?
When I ask for reference angle, if I don't ask for any other conditions, it's always reference angle. If I ask you, what is the arctangent of negative square root of 3? Reference angle. It is not reference angle, it is principal values. Right? If I ask for arctangent of negative square root of 3, it is principal value. If I ask you what is the arctangent of negative square root of 3 between 0 and 2 pi, then you're going to find the angle between 0 and 2 pi. The process is the same. What is my reference angle? My reference angle is the same every single time.
And 0 and 2 pi is all 4 quadrants.
Isn't it?
Yeah. So you have to find which one's negative or.
SOHCAHTOA, not SOHCAHTOA, but all students take calculus.
Yeah.
Where is sine positive? Where is cosine positive? Where is tangent positive? You gotta take all those principles and put them together.
And then you find the 2 that work.
Not necessarily work, but 2 that are the correct answer, yes.
That work with the sign.
Whatever I'm asking for. try a couple more. Folks, we've been working on this for 2 weeks now. We gotta get it. We got to get it. Let's see. Arc cosecant of 2. Alright? My calculator or my head don't have a button for cosecant, so I need to change it to sine. So I'm looking for the arc sine of 1/2. Right? What is my reference angle? 5 or 6. Principal values would be where?
First.
First or the fourth?
Yeah, sorry.
I'm positive, so I'm looking for what?
First.
First, so therefore my answer is,
Positive.
which is
5 or 6.
5 or 6. Alright, but now what if I ask for the values between 0 and 2 pi? 0 and 2 pi. Now I'm looking for what quadrants?
All 4.
Or 4.
First and fourth.
What 2 quadrants am I concerned about?
The first and fourth.
First and second.
First and
That's where sine is positive, first and second. I already got the first, 5 or 6, right?
Yeah.
What's the second?
5 or 6.
5 or 6.
Yeah.
Alright,
Did I get the right plus like 2 pi in or something?
that's if I wanted all of them, alright? So, if I asked for all the angles, and I didn't give you a range, then yes, plus 2 pi. Alright, that's between 0 and 2 pi.
Mm-hmm.
What if I asked between 8 pi and 10 pi? That's 0 to 2 pi, right? Well, how many more turns do I have to do? 4 more, right? Every 2 pi.
Oh.
Or is it 8 pi? That's 1 turn, right? Is there 1 more turn? There's 1 more turn. There's 1 more turn.
Got it.
So we needed 4 more turns. I started doubting myself too. I started, wait a minute, wait. Yeah, 4 more turns. Right? But am I in the same place?
Yes.
Yeah, coterminal angles, same place. So what am I have to add to each one of these to get to the place I want to be?
4 pi. 2 pi. 8 pi? 10 pi. I don't know.
Alright? What is 1 turn?
1 turn is 2 pi.
But, and
12 pi.
12 pi or 6?
Oh, you meant in the fraction.
Yeah.
Sorry.
Okay? How many of those am I add?
To get,
How many turns did I make?
you mean,
4 turns, right?
so 48 pi.
So I'm gonna add 48 pi to each one. That means this is gonna be
49 pi, so over 6.
49 pi over 6,
And then
And this is gonna be
53 pi over 6.
53 pi over 6. Alright? If you wanna make sure, to double check, well, 49 divided by 6 is what?
40, I mean, well, it's 8.
8 point something, right?
Yeah,
So I am between 8 and 10.
yeah.
And 53 divided by 6 is?
Oh, it's not exact, it's not 10 yet, it's like 9.
Or 9.7, so I'm still between 8
It's not even 9 yet,
and 10.
because 9 times 6.
So that's where you're gonna check out, okay, am I in the right place? Yes, because I am between those two numbers, 8 and 10. Okay?
So, you always multiply the fraction by how many more turns you did and then add it.
I need to figure out how many more turns I have to go. So, and you go by 2 pi's. Alright, 0, 2, 4, 6, 8, and that will tell you how many terms. Okay?
Oh wait, so 49 is like 12 pi over 6 plus 4? Because you do 4 times.
If I'm doing 4 terms, I'm doing this times 4.
How can you get 43 pi over 6?
I got 49 pi over 6.
Isn't it? I
What's-
mean like
What's 12 pi over 6 times 4?
48.
Plus pi over 6.
12.9 pi.
48 plus 5.
52 pi over 6.
50 what?
53.
Yeah, okay. Thought you were doing some kind of Vietnamese math. Just kidding. All right. Now, if I wanted all the angles, we would do what?
You have to add plus, would it be 4 pi n or 2 pi n?
2 pi n. Then I go 1 turn around. And then 5 pi over 6 plus 2 pi n. Okay? Okay? Same principle, same thought process. What are my reference points?
0,
Not reference angles, but reference points.
2 pi and pi.
Pi and 2 pi. Alright, pi and 2 pi. So here, the arc cosine of negative 0.3567, and I want to be in radians. Alright, I want to be in radians. What will my calculator give me? What would my calculator give me?
You want us to do it?
No, I'm asking what kind of angles will my calculator give me?
The principal value.
Principal values. Principal values. Okay? So that means I'm looking for what value do I have? What kind of value do I have? Negative. So that means my calculator is going to give me an angle in what quadrant?
Positive quadrant.
Negative.
No, it's gonna be positive.
What's my principal values for cosine?
1, 2,
1 and 2. And where is cosine negative?
4.
Whoa.
Second.
2 and 3.
Second. Out of my principal values, where is cosine negative? Second. So my calculator is going to give me an angle in this second quadrant. All right, the second quadrant.
It's 1.9355.
What is it?
1.9355.
1.933.
No, 1.9355.
Oh, I'm sorry. 355. Now, if you notice, that is in the second quadrant, because the second quadrant, pi over 2 is somewhere around 3.14 divided by 2, 1.5.
1.57.
Okay? And all the way to pi would be 3.14.
Yeah.
So I know I'm in the second quadrant. All right? What other angle do I need to find? Where else is cosine negative?
The third.
Third quadrant.
So you
What do I need to know to be able to find that angle in the third quadrant?
What you're doing? What do you mean what we know?
To be able to find that angle in the third quadrant, what do I need to know?
You need to subtract. You need to do pi minus
Pi minus what though?
1.9.
No.
What?
What do I have to subtract from pi? It's always my,
Reference.
what's that?
Reference.
Reference angle. Reference angle. This is not the reference angle. This is
Do we have to subtract -3.567?
this angle. I need to know this angle.
So
So
we
first you
subtract,
do pi minus.
we do pi minus, well, plus.
Alright, I'm gonna do pi minus this,
Mhm.
which is,
Wait, didn't you just tell us that we're not doing 1 point? You just told us we do not subtract pi from 1.9355. You just told us not to do that.
well, you were saying that incorrectly to my question I was asking.
Okay.
So we subtract pi from one.
I gotta find this angle. I gotta find this reference angle.
1
It's 1.21. 1.21.
1.21,
One.
two more decimals,
Oh,
No,
1.2060.
269,
So.
okay,
1.
2.061.
Yeah.
Alright, so that's my reference angle. Now I can find that angle.
So pi plus.
Then I do pi plus 1.2061.
4.348.
4 point what?
348.
It's not 4, it's 1. I mean, it's 3 point, it's pi plus 1.261, right?
Yeah.
2601, right? It's
It's 2601 or 2061?
2601.
Okay, I had it wrong.
Oh, wait, no, 2061, sorry, my bad, I misspoke. Hold on.
Okay.
So we do.
4.348,
Mhm.
8 what?
Oh, you need more? Then it's 3.3476. That's the 77.
Because usually they will always want you to the 4 decimal places.
Okay.
Cosine is always a difficult one because they don't always give you the reference angle. Sine and tangent, they're always gonna give you the reference angle, whether it be positive or negative. Let's look at this one. Arctangent of -3.5216. What angle are they gonna give me?
They give you a negative.
But again, negative angle, that would be the angle in the,
4.
remember we're talking about principal values, my calculator is always gonna give me principal values,
Fourth.
4th quadrant. Alright, what is it?
Arctangent, negative, what's the number you have?
Oops.
-3.5216. Oh, it might be positive since it's arc. No, it's negative. 1.2941.
Is that between 0 and 90? 0 and pi over 2?
Yes.
Yes, it's lower than -1.5. That's a reference angle.
Mhm.
Where else is tangent negative?
Second,
Second quadrant. How do I find the angle in the second quadrant?
you have to subtract pi, you
No,
do pi
subtract.
minus, or you have to do
Correct,
pi?
because we're not at pi yet, so we subtract from pi, gives me,
What do you want us to subtract? Pi?
4.4357.
what is it?
4.4.
No, that's not right.
No. Thought you subtracted from
Is it pi minus
So,
negative?
yeah.
No, not pi, minus negative, I want to subtract the reference angle. My reference angle is always between 0 and 90. My reference angle is always positive.
So
Pi minus 1.2941.
It's 1.847.
1.8475.
475.
There's my angle in the second quadrant. If I want it from 0 to 2 pi, I also want the angle where?
Positive, negative.
Where else is tangent negative?
Well, it's fourth and third. I mean, it's fourth and second, sorry.
4th quadrant. But I don't want the negative angle, I want the positive angle.
Ah, I don't like this.
So how do I get the positive angle?
2 pi minus.
Alright, add 2 pi to this. Because if I'm here, alright, I want to go back to here.
4.9891.
What's that? 4.9891. So what you have to do, you gotta remember the principle. Okay? If I need the angle in the fourth quadrant, what I'm gonna do? I'm gonna take my reference angle and subtract from 2 pi. If I want the angle in the second quadrant, I'm gonna take my reference angle and subtract from pi. If I want the angle in the third quadrant, I'm gonna take my reference angle and add to pi. If I want the angle in the first quadrant, my angle in the first quadrant is always going to be my reference angle. Reference angle in the first quadrant, angle in the second is pi minus the reference angle. Angle in the third quadrant, pi plus the reference angle. And in the fourth quadrant is 2 pi minus the reference angle. Hence we get the idea of reference angles are very important. We have to make sure we get the correct reference angle. Yes?
So why is it 2 pi plus 1 plus 1.2941?
It's not 2 pi plus.
Was pi minus?
Again, here's my diagram. This is the angle my calculator gave me. I want that angle. So how do I find that angle?
2 pi minus 1.2941.
You can do it that way, or you take negative 1.2941, add 2 pi to it. Both are the same thing.
Oh, it's the same thing.
Basically, yes.
Thank you.
All right? And then how would I find that angle?
Pi minus.
I get pi minus the reference angle or add pi to it. Okay. Draw a picture if you have to, put it mentally in your mind, draw a picture on paper, whatever you need to do to be able to picture where those angles are. But this is where we're falling short, right here. All right? These problems, which should be easy problems, we're falling short because we are not picturing where the angles are. They are very important to be able to figure out what angles we're talking about. All right, so here, arc cosine is 42/2.
Pi over 4.
Principal value,
Pi over 4.
pi over 4. Now with the angles, the arc cosine is 42/2. All the angles between 0 and 2 pi.
0 and 2 pi, so that would be, you'd have first,
Which is?
which would be pi over 4. And then you also have the fourth one,
Mhm.
which would be,
9.
Yep.
Okay. Now between -6 pi and -4 pi.
so now we go clockwise, right? Because it's negatives.
Mhm. How many turns do we have to go?
You have to go 3.
3 turns, correct?
Mhm.
3 turns is how much?
6 pi.
Or 1 turn is how much?
2
2
pi.
pi.
Which is how many pi over 4? 8 pi over 4, so 3 turns would be
24 pi over
24 pi over 4. So that means we're gonna be
25 pi over 4, oh no, 23 pi over 4.
negative 23 pi over 4.
And then you're gonna have, would it be it wouldn't be negative, would that one be, would 7 pi over 4 be negative or positive?
Be negative, because again, we're going clockwise.
So it would be 17 pi over 4, negative 17 pi.
Wait, how'd you get the 24?
3 turns,
Wait, how we know what 3 turns again?
2 pi. Right? 1 turn is 8 pi over 4, right? So 3 turns would be
Oh, okay, I see.
24 pi over 4,
Mhm.
going clockwise.
I just use it.
So you
Oh,
have,
2
so
pi,
you,
6 pi.
so you keep the denominator.
Always get the denominator, yes.
4 pi, 6 pi, 3.
Alright, 4 goes to negative 23, how many times?
Goes in there, 6
Five.
times, not 6, 5 times.
Negative 5, correct?
Mhm.
Yeah.
So I'm between negative 4 pi and negative 6 pi. And 4 goes in
4.
negative 17, how many times?
4 times.
Negative 4. So I'm still between negative 4 pi and negative 6 pi.
Mm-hmm.
Okay? All the angles,
Would that be from the pi over 4, or the 7, and the 7 pi over 4? So pi over 4 plus 2 pi n, right, plus 2 pi n. And then 7 pi over 4 plus 2 pi n.
alright? So this is going to be easier because if I look at these angles here, pi over 4 and negative pi over 4, are they the same angle?
Yes.
Yes. So I could just go plus or minus pi over 4 plus 2 pi n.
Wait, can you say it again?
Instead of going pi over 4 plus 2 pi n and 7 pi over 4 plus 2 pi n, I could just go pi over 4 and negative pi over 4, would simplify my writing a little bit, plus 2 pi n. That would give me all the angles, positive and negative. Okay? Yes, ma'am.
And for the 7 pi over 4, it's, to get the fourth angle, it's 2 pi plus 4 pi over 4.
Math Excel, don't forget Math Excel tonight. Say that again.
How do you get the fourth quadrant of 7 pi over 4? That's
What's my reference point?
4 pi over 4.
My reference point, not my reference angle, my reference point. What are my reference points? Pi and 2 pi. Fourth quadrant, did I get to 2 pi yet? If I'm in the fourth quadrant, did I get to 2 pi yet? No. So therefore I'm going to do what to find that angle?
Subtract
Subtract. Subtract what?
4 pi over 4.
Reference angle. My reference angle is what? Pi over 4. Subtract pi over 4 from 2 pi over 4. I'm sorry, subtract pi over 4 from 2 pi. Two pi is the same thing as what?
8.
8 pi over 4. You're welcome.